What is to require to find is x to the power of 8 y raised to 5 coefficient in the expansion of x plus y to the power of 13. N by 2 plus 1th term is the middle term. So what is n here? 6 by 2 plus 1th term. 6 by 2 is 3 plus 1th term. That is nothing but the 4th term. 4th term is the middle term. To prove p of k plus 1 is also 2. Just add k plus 1 whole square on both sides of equation number 1. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the question paper in part A and part B. So today also I will take few more problems in part B. Now let us come to part B. In part B we have already discussed one question, and the second question is like this, question number 7, which contains 15 marks. There are two questions, A and B. So question A is followed by two questions. Find the minimum number of students in a class such that 3 of them are born in the same month. So what is the question? Find the minimum number of students in a class. So we have to find the minimum number of students in a class such that 3 students are born in the same month. 3 of them are born in the same month. This can be solved using the concept of a pigeonhole principle. We have studied regarding the pigeonhole principle. Using the concept of pigeonhole principle, we can solve this problem. For this, the marks will be 4 marks. And the second question is like this, write the ordered pair. What is to write is the ordered pair. The ordered pair of the relation on the set 1, 2, 3, 4 corresponding to the following matrix. The matrix form is given. We have to write the ordered pair for this given corresponding matrix of 4 rows, 4 columns. For this also 4 marks, 4 plus 4 is 8. So first question carries 8 marks and the second question is 7 marks. 8 plus 7 is 15 marks from this. Very easiest. Now what is the first problem? Find the minimum number of students in a class such that 3 of them are born in the same month. So on the second problem is we have to find the ordered pair for the relation 1, 2, 3, 4 corresponding to the following matrix. Right. Now let us come to the first problem. So the first problem can be solved using the concept of a pigeonhole principle. Right. Now let us come to the first one. Now using the concept of pigeonhole principle. So find the minimum number of students in a class such that 3 of them are born in the same month. So here the number of months, therefore now the number of months in an year, number of months n is equal to 12 months. So in an year the number of months must be 12 months in an year. So this is number of months per year in 1 year. Right. Now what is the given condition? Given condition is that at least 3 of them are born in the same month. How many of them? 3 of them are born in the same month. Means given k plus 1 is equal to 3. This is the given condition. That's it. What is given? K plus 1 is equal to 3 is the given condition. 3 of them are born in the same month according to pigeonhole principle. Now therefore what is the value of k here? K is equal to 3 minus 1, that's equal to 2. So therefore k is equal to 2 and n is equal to. Now from pigeonhole principle, from pigeonhole principle, what is the formula we are going to use? M is equal to k into n plus 1. Capital M is equal to kn plus 1. So M is equal to, substitute the value of k. What is k here? K is equal to 2 into n is equal to 12 plus 1. 12 2s are 24 plus 1, that's equal to 25. M is equal to 25, right? So that means the number of students in the class must be 25 students. So therefore the number of students in the class is equal to 25. So if 25 number of students are there, then at least 3 students must be born in the same month. This is how we are going to simplify using the concept of a pigeonhole principle. So, very simple problem, just the number of months in an year is 12 months and given that k plus 1 is equal to 3, therefore, k is equal to 3 minus 1 is 2. Using pigeonhole principle, the number of students m is equal to k n plus 1, k into n is 12 plus 1, 24 plus 1 is 25. So, therefore, minimum number of students must be 25 students must be there, so that at least 3 of them are born in the same month. Now, let us come to the next second part of this problem. What is the second part of this problem? So, we have to find the ordered pair for this matrix. So, what is given? MR is equal to given matrix. MR is equal to, let me write the matrix of 4 rows, 4 column. So, 1 0 1 0 0 1, again 0 1 0 1 1 0 0 0 1 1 0 0 1 1, again 1 0 1 0 1 0 1 0. This is the matrix given, right? So, what are the elements of the set? The set contains 1 2 3 4. Now, the matrix, the solution for this solution, MR is equal to, write down 1 2 3 4 and the matrix 1 2 3 4. So, this is the matrix. Okay. Now, what is given here? The same values, just enter the same values, 1 0 0 1 0 1 1 0 0 0 1 1 1 0 1 0. Now, let us come to the answer. Write down the relation. The relation R is nothing but the set of all ordered pairs of this matrix. So, 1 comma 1 is 1, 1 comma 1 we can take, 1 comma 1, again 1 comma 2 is 0, 1 comma 3 is also 0, we can write 1 comma 4. So, 1 comma 1 and 1 comma 4. Similarly, 2 comma 1 is 0, 2 comma 2 is 1, 2 comma 2 and 2 comma 3. Similarly, 3 comma 1 is 0, 3 comma 2 is 0, 3 comma 3 and 3 comma 3 and 3 comma 4, right? And the last, here it is 1, here it is 1, 4 comma 1 is 1, we can write 4 comma 1 and 4 comma 3. So, these are the elements of the set R which contains all the ordered pairs. So, 1 comma 1, 1 comma 4, 2 comma 2, 2 comma 3, 3 comma 3, 3 comma 4, 4 comma 1 and 4 comma 3. So, 1 comma 1 and 1 comma 4, whereas 2 comma 2 and 2 comma 3. Similarly, 3 comma 3 and 3 comma 4 and 4 comma 1 and 4 comma 3 are the required ordered pair for this given matrix whose relation is denoted as capital R. Okay, that's it. Hope you followed, right? So, if you do this much, definitely you will get a 4 marks. So, this is very simple concept. Now, let us come to the next problem. Now, determine the coefficient of x raised to 8, y raised to 5 in the expansion of x plus y to the power of 13. So, what is required to find is x to the power of 8, y raised to 5 coefficient in the expansion of x plus y to the power of 13. Okay, using binomial theorem, we are going to expand this. Now, comparing with x plus y to the power of 13, comparing this with x plus a to the power of n. N is equal to 13, x is equal to x and a is equal to y. What is the nth term? Tr plus 1 is equal to ncr x raised to n minus r into a to the power of r. So, Tr plus 1 is equal to n is 13cr x to the power of 13 minus r into a is y to the power of r. So, Tr plus 1 is equal to 13cr x to the power of 13 minus r y to the power of r. This is equation number 1. Now, for coefficient of, what is the coefficient to be determined? X raised to 8 and y raised to 5. Equate this, x to the power of 13 minus r and y to the power of r is equal to x raised to 8 and this. Equate this. So, if we equate this, let us say these are equal, then what you will get? Directly you can write r is equal to 5. See, r is equal to 5. R we can also take from 13 minus r is equal to 8. That means 13 minus 8 is equal to r is equal to 5. So, the value of r is 5. Just put r is equal to 5 in equation number 1. That's it. If you put r is equal to 5 in equation number 1, you will get t, what is 5 plus 1? T 5 plus 1 is equal to 13c 5 x to the power of 13 minus 5 y to the power of 5. So, T6 is equal to 13C5 x to the power of 13 minus 5. 13 minus 5 is 8, y to the power of 5. See, this is the coefficient. So, what is to find? X raised to 8 and y raised to 5. So, this is the coefficient. Therefore, coefficient of x raised to 8 and y raised to 5 is 13C5. If you want, you can simplify this. 13C5 can be written as 13 factorial divided by 5 factorial into 13 minus 5 is 8 factorial. If you simplify, you will get the answer. That's it. Okay. So, if you want, we can simplify this. That's equal to 13 into 12 into 11 into 10 into 9 and 8 factorial gets cancelled. 5 into 4 into 3 into 2 into 1. So, 5 2s are 10 gets cancelled. 3 3s are 9 again. 4 3s are 12. So, what is left over is 13 into 3 into 11 3s are 33. So, if we simplify this, how much you will get? 1287. So, 1200. Coefficient of x raised to 8, y raised to 5 in the expansion of x plus y to the power of 13 is 1287 is the required answer. 1287. If you do this much, definitely you will get 7 marks from this. Hope you followed. Okay. Now, let us come to the next problem. Second question, the choice, internal choice for this is A and B. Prove by the method of mathematical induction that 1 square plus 2 square plus 3 square plus etc. n square is equal to 1 by 6 times n into n plus 1 into 2n plus 1 for all n belongs to z. Yes, this is again a 7 marks question. So, for this you are going to get a 7 marks. Now, this is by mathematical induction. Now, what is given? Given that, let us consider this is the given expression. Now, let us come to the solution. So, proof. Given P of n is equal to, what is given? 1 square plus 2 square plus 3 square plus etc. plus n square is equal to n into s is equal to n into n plus 1 into 2n plus 1 divided by 6 for all n belongs to capital N plus, right, for all n belongs to n. Now, so this can be done by the method of mathematical induction. So, what is the mathematical induction? Let us prove the statement is true for some positive integer n is equal to 1, then for some another integer, say for positive integer n is equal to k. If it is true for n is equal to k, means then prove that it is true for k plus 1 also, right, that is it. Now, let us put n is equal to 1. If you put n is equal to 1, so P of 1 is 1 square plus 2 square plus 3 etc. plus 1 square. So, this implies 1 square is equal to 1 into 1 plus 1 into 2 plus 1 divided by 6. 1 is equal to 2 into 3 by 6. So, this implies 1 is equal to 1. LHS is equal to RHS. That means what you say? Therefore, the statement is true for n is equal to 1. Therefore, P of n is true for n is equal to 1. This is the first step. So, let us prove the statement is true for n is equal to 1. Now, let us prove the induction method. Now, to prove this is the basic step, and the induction step is to prove that the statement is true for some positive integer n is equal to k. To prove that yes, P of n is true for some positive integer n is equal to k. This is P of k is equal to 1 square plus 2 square plus 3 square plus etc. plus k square is equal to, just replace n by k into k plus 1 into 2k plus 1 divided by 6. Let us represent this as equation number 1. So, now to prove that P of n is true for some positive integer k. So, therefore, 1 square, 2 square, 3 square etc. k square is equal to k into k plus 1 into 2k plus 1 divided by 6. Now, what is to prove? To prove that P of k plus 1 is also true. Induction method. Now, to prove that P of k plus 1 is also true. Just very simple. To prove P of k plus 1 is also true, just add k plus 1 whole square on both sides of equation number 1. Just add k plus 1 whole square. Adding adding k plus 1 whole square on both sides of equation number 1. So then what you will get? Equation 1, p of k such that 1 square plus 2 square plus 3 square plus etc. plus k square plus k plus 1 whole square is equal to what we have? K into k plus 1, 2k plus 1 divided by 6 plus k plus 1 whole the square. Now simplify this. If we simplify this, this is equal to, let us take LCM, 6 is the LCM, k into k plus 1 into 2k plus 1 plus cross multiplied 6 into k plus 1 whole the square. This can also be written as, now if you observe carefully, you can take the common factor, you can take k plus 1 as the common factor, k plus 1 is taken out and what is left is k into 2k plus 1 plus 6 times 1k plus 1 divided by 6. Now simplify this. So this can be simplified like this. This is k plus 1 into, multiply this, 2k square plus k plus 6k plus 6 whole divided by 6. This can also be written as k plus 1 into 2k square plus 7k plus 6 divided by 6. Now factorize this. So if you factorize this, 2k square plus 7k plus 6. So if you factorize this, the factors for this you are going to get is cross multiply 2k into k, this is 3 into 2, 2 2s are 4 plus 3 is 7. So you are going to get the factors as k plus 2 into 2k plus 3. So the factors for this are, so this is, I will write here, this is equal to k plus 1 into, what are the factors? K plus 2 into 2k plus 3 divided by, so this can also be written as k plus 1 into k plus 1 plus 1 into 2 times k plus 1 plus 1. See, if we multiply, 2k plus 2 plus 1 is 2k plus 3 divided by 6. Let us represent this as equation number 2. Now observe equation 1 and 2 carefully. Wherever there is k in 1, we have k plus 1. See, here it is k, we have k plus 1. Again, k plus 1 can be written as k plus 1 plus 1 and 2k plus 1 can be written as 2 times k plus 1 plus 1. So from equation 1 and 2, we can say that wherever there is k, we have k plus 1 in equation number 2. Therefore, from 1 and 2, we can say that p of k plus 1 is also true, P of k plus 1 is also true. Hence, by induction, hence p of n is true for n is equal to 1. P of n is true for n is equal to 1. And the second one, p of k is true implies p of k plus 1 is also true. Therefore, what is the conclusion? P of n is true for all n belongs to n plus. For all n belongs to n plus. So, P of n is true for all n belongs to n plus. So, if you do this much, definitely you will get 7 marks. Very easy. So, definitely you will get one question from this mathematical induction. Right. Hope you followed. Now, let us come to the next problem. What is the next problem in this is, find the term independent of x, also middle term in the expansion of 3x square by 2 minus 1 by 3x whole to the power of 6. Now, what is to find the term independent of x and also the middle term in the expansion of this. Now, let us come to the first concept. What is given? Given is 3x square. Let us come to the solution. So, 3x square by 2 minus 1 over 3x whole to the power of 6. Now, comparing with x plus a to the power of n, if you compare this with x plus a to the power of n, what is n? N is equal to 6, x is equal to 3x square by 2 and a is equal to minus 1 by 3x. Let us find out first the term independent of x and the middle term. First, the term independent of x. We know the nth term tr plus 1 is equal to ncr x raised to n minus r a raised to r. What is the nth term? Tr plus 1 is equal to ncr x raised to n minus r a raised to r. Now, just write down here TR plus 1 is equal to N. N is 6, C, we don't know the value of 6CR, X, what is X? 3X square divided by 2 whole to the power of 6 minus R into A minus 1 over 3X whole to the power of R. So, this is TR plus 1 is equal to 6CR. This can be written as 3 by 2 whole to the power of 6 minus R into X to the power of 2 6 are 12 minus 2R into minus 1 to the power of R into 1 over 3 to the power of R divided by X to the power of R. So, this is the general term. What is required to find? Find the term independent of X in the expansion. So, let us find the independent term. For independent of X, independent term means nothing but the constant term. For independent of X, let us simplify this. 6CR 3 by 2 whole to the power of 6 minus R, X to the power of 12 minus 2R, and take this to the numerator. This becomes X raised to minus R and minus 1 to the power of R into 1 by 3 to the power of R. So, this becomes 12 minus X to the power of 2R minus R, that is nothing but X to the power of 12 minus 3R. Equate this to 0 for independent term. For independent term, X to the power of 12 minus 3R is equal to X power 0. So, which implies 12 minus 3R is equal to 0, 3R is equal to 12, R is equal to 12 by 3 is 4. Now, if you put R is equal to 4 here, put R is equal to 4, put R is equal to 4, you will get T4 plus 1, T5 is equal to 6C4, 3 by 2 to the power of 6 minus 4, 6 minus 4 is 2 into X to the power of, what you will get, 12 minus 12 is X raised to 0 into minus 1 to the power of R, R is equal to 4 into 1 divided by 3 to the power of 4. So, this is minus 1 to the power of 4 is plus 1. So, 3 by 2 whole square, that is nothing but 6C4 into 3 square is 9 divided by 4 into minus 1 to the power of 4 is plus 1 and 1 by 3 to the power of 4, 1 over 3 to the power of 4. So, if you simplify this, you will get the term which is independent of. So, this does not contain X. So, therefore, the independent term or the constant term is 6C4 9 by 4 into 1 by 3 to the power of 4 is the constant term. This is the constant term. Okay. Now, the second part. What is the second part of this problem? Middle term in the expansion. So, to find the middle term, so n by 2 plus 1th term is the middle term. So, what is n here? 6 by 2 plus 1th term. 6 by 2 is 3 plus 1th term. That is nothing but the 4th term. 4th term is the middle term. Now, to find the 4th term, so T4 is the question mark. To find 4th term, R plus 1 is equal to 4 means R is equal to 3. That's it. Now, put R is equal to 3. If you put R is equal to 3, 3T plus 4, 3 plus 1 is equal to 6C3, 3 by 2 whole to the power of 6 minus 3 X to the power of 12 minus 3 into 3, that is 3 into 3 minus R, and minus 1 to the power of 3 into 1 over 3 to the power of 3. That's it. This is the middle term. Simplify this. 6C3, 3 by 2 whole to the power of 3, X to the power of 12 minus 9, minus 1 cube is minus 1 over 3 cube, 3 3s are 9, 9 3s are 27, or we can write 1 over 3 cube as it is. So, this is 6C3 along with negative sign, 3 cube divided by 2 cube into X to the power of 12 minus 9, 12 minus is 3 into 1 over 3 cube. So, this 3 cube and 3 cube gets cancelled. So, what is the answer we are going to get is minus 6C3 1 by 2 cube, 2 cube is 2 to the 4, 4 to the 8, 1 by 8, 1 over 8 times x cube, that is all. Minus 6C3, 1 by 8 x cube is the required answer, that is it. This is how we are going to find the middle term in the expansion, the middle term is the fourth term. T4 is the middle term in the expansion. So, because see, you know, this given equation contains 6 plus 1. 6 plus 1 terms means 6 plus 1 is equal to 7 terms. In 7 terms, the middle term is 1, 2, 3, 4, 5, 6 and 7, which is the middle term. The fourth term is the middle term. That's it. Okay. This is how we are going to solve this problem, right? So, therefore, the conclusion is, therefore, the middle term is T4 is equal to minus 6C3 into x cube divided by 8, and then the independent term is equal to, what is the independent term? So, the independent term is 6C4 into 9 by 4 into 1 by 3 to the power of 4. 9 by 4 into 1 by 3 to the power of 4. That's it. This is the required answer. Hope you followed. Okay. These are few problems based on a model question paper, right? So, that's all regarding this session. Let us meet with the different types of questions in the next session. Thank you very much.